Welcome to our series on probability theory. My name is Mark Ledbetter, and this is lecture video 12, and we are starting section 2.2 in the book called Mathematical Expectation. So let's review what we did last time. We talked about discrete random variables, and we said that if x is a discrete random variable, then the PMF, or probability mass function, is given by f of x is equal to p of x equals x. P of x, the random variable, is equal to little x, an actual value. We went over the properties of f of x. It's greater than 0 when x is in the space. It's 0 otherwise. The sum of all the probabilities in a distribution have to equal 1. For an event in S, the probability of that event occurring is equal to the sum of all the probabilities for x in that event. Then we talked about a CDF and some important properties of the CDF. We also introduced the discrete uniform distribution. We introduced its mean, its PDF, its mean, and we'll talk about its variance probably in this or the next section. We also discussed line graphs and probability histograms. So in section 2.2, we are going to talk about a concept called mathematical expectation. So this is a statistical concept, and we're going to specifically discuss the discrete case. We're also going to talk about the expectation of a function of x. Then we're going to talk about, in a future video, the properties of expectation, and we're going to introduce the geometric distribution. Okay, so what is mathematical expectation? Basically, we're saying if we repeat an experiment a large number of times, or we call it over the long haul or in the long run, what do we expect to occur for that random experiment? It also can be considered a weighted average, and we'll talk about that a little later. So let's jump right in and define the expectation. And this is something you need to be very comfortable with. So I suggest that if you need to stop and read the slide, do so. Make sure you're absorbing this. We're again talking about a random variable that's discrete. We're saying if it has m elements in its space or support, then the expectation of x would be this. E of x is the sum of x in S, the sum of x times f of x over all of the values of x that are in the space or support. And this, we're saying, we write it this way if it's not sequential. If the values are sequential, then we could write it like this. We could say the sum of xi, f of xi, that product, the sum of it from I equals 1 to m. Okay, and so a lot of times we do that, but if the values of x are not sequential, then we'll use this, which is a general expression for it. By the way, I want to note right off that the mean of x is e of x, not e to the x, e of x. So the expected value of a random variable is its mean, which is the mean of its distribution. If x is infinite but countable, the number of elements in its support, it has an infinite but countable number of elements in its support. That's one of the definitions of discrete. Then here is an expression, again, for the expectation, the sum of the product, x sub I, f of xi, from I equals 1 to infinity now. And this is when they're sequential. If they're not sequential, again, we can write it in the same form that we had before. I want to recall to your attention, you need to understand what the summation means. So when you see it, it needs to immediately be clear to you that the sum of this is, I'm going to plug in I equals 1, I equals 2, all the way up to I equals m, and we're adding. Okay, it's the sum. But remember that multiplication happens before addition, so this here occurs before the summation. So let's look at a game of chance. We're going to roll a fair die, and if a 1, 2, or 3 occurs, we're going to call that event A, and the player, the person playing the game, is paid $1. Event B is 4 and 5. So if that happens or occurs, then the player is paid $2. And if C occurs, which is the number 6, then the player is paid $3. So we need to define the random variable here, and this is extremely important. You always need to define your random variable. What does it stand for? Don't just assume people know. They may not. In fact, most times we won't, unless you tell us. So let the PMF of this be the probability mass function. F of x equals 4 minus x over 6, and we're letting x equals 1, 2, or 3. So if you write out the values here and add them up, you see that they add up to 1, so it is a probability distribution. So we're going to repeat the game a large number of times, and so then we want to find the expected value. So this is E of x. So we're going to take x times f of x for each value of x, and we're going to add them up. So x is 1, and the PMF is 4 minus x. So 4 minus 1 is 3, so we have 3 6 is the f of x. So 1 times 3 6, 2 times 2 6, 3 times 1 6, we get 10 sixths dollars. And so the expected payback to the player is 5/3 dollars, or $1.67. The house can expect to pay 5/3 of a dollar on average back to the player. So the house needs to charge more than this in order to come out ahead or profit over the long haul. So if we charge $2 a game, then our expected profit is $1 per game. Expected. Obviously, it's not going to be, because they're going to pay $2 and we're going to pay either 1, 2, or 3 back to them. Okay, so this is an average or an expected value over a long haul. Now, let's say that we are interested in a function of x instead of just x. We're going to call it u of x. So u is a function on x, and we'll even say that y is equal to u of x. When we do this, because x is a random variable, guess what? Y is also a random variable, and it has its own PMF, mean, etc. So in this example, let's let y equals x squared. Now we need to look at what x is. So we take the square root of y. Remember the plus or minus. But in this case, x is 1, 2, or 3, so it's always positive. So we only have a 1-to-1 function because of what x is, how it's defined. So x is the square root of y, and now we plug that in to get g of y, and we end up with this expression here. But don't forget to change your y. Y is x squared, so when x is 1, y is 1, x is 2, y is 4, x is 3, y is 9. So the s of y will be the support of y. Then the mean, mu of y, can be written as this expectation, the summation of y times g of y when y is in s of y. And this is what we get. We don't get the same value because we're doing a function of x, not x. We get 1 times 3, 6 plus 4 times 2, 6, etc. We get $3.02, or a third, so $3.33 instead of $1.67. So a big difference. Here, the house could charge $4, and the expected payoffs, 4 minus 20 over 6, is 2/3 of a dollar. Okay, so we're expected to make a profit of 2/3 of a dollar per game. But it may look more enticing to the players because they could net $5, $0, or negative $3. So, but this gain of $5 may make them think that this is a lot better because they're getting 9 paid back to them. So what would be the expected profits for the house if y is equal to x cubed and the cost to play was $10? I'll leave that to you to figure out. That'll be a good practice. I hope you'll pause the video now and do that. So E of y is equal to the sum of y times g of y, which is also the sum of u of x times f of x. We're not going to provide the proof, but that is true. So now we're going to give the definition. If f of x is the PMF of discrete random variable x with space s and the summation of the absolute value of u of x, f of x, which is, oh, I didn't write this right. Let me correct that. This is supposed to be over here, okay? This is the absolute value of u of x because f of x is always positive, okay? And if this is finite, then the expectation is defined, and we have e of u of x is equal to the sum of u of x times f of x for x in S. So the definition of e of u of x requires the absolute convergence of this quantity, which is what we showed up there. And again, we have the absolute value of the whole thing that's being summed, and because f of x is positive, then we can pull it out of the absolute value. And this has to be finite so that we're able to rearrange these terms, the actual terms that we're adding up. You can't do that unless this converges absolutely. And in fact, you can see that the sum of two functions is equal to the sum of each of the functions added only if the original converges. Otherwise, you can manipulate things that don't converge and make you think that it does or converges to something different. All right. Since u of x can be negative, we need absolute convergence here. So the next remark is that e of x is related to the physical property of center of mass. You know what? I am going to say, let's not talk about this now. We'll talk about it in the next section. So here's some useful facts that you need to know, so definitely put these on your formula sheet. The sum of I from 1 to n, so in other words, the sum of the positive integers up to an n is equal to n plus 1 over 2. And for the squared values, we have n plus 1, 2n plus 1 over 6. You can prove these by induction. So we're going to do a quick example. Let x be the number of dots facing up when a fair die is rolled. And we want to find the expected value of g of x when g of x is 2x squared plus 1. So e of g of x equals the sum of g of x, 2x squared plus 1, don't forget your parentheses, times f of x. And this is going to be from 1 to 6 because that's what the die can have. And note that f of x equals 1/6, x equals 1 up to 6. Okay? And then e of g of x is equal to the sum from x equals 1 to 6, 2x squared plus 1 times 1/6. We can pull the 1/6 out to the front because it's a constant, 2x squared plus 1, and we have x from 1 to 6. Now, because we are using a finite number of elements here, this summation converges. We're not summing to infinity, so we can break this sum up as 1/6, and we'll do the sum of 2x squared plus the sum of 1, x equals 1 to 6, x equals 1 to 6. All right, now, let's look at this summation here. This summation here, and we have the sum of 2x squared. So I can pull the constant out to the front of that summation. Now, make sure that you pull the 2 out to here. Don't pull it all the way out because there's no 2 here. It's only in the one summation. So I have x squared from x equals 1 to 6 plus, now, this summation says for x equals 1 to 6, there's no x in here. All there is the constant 1. So when I take 1 and add it for x equals 1, it's still just 1. This is like saying f of x equals 1. Okay? So it doesn't matter what you change x to, you're still getting 1. So for each of the summations, 1 plus 1 plus 1 plus 1 plus 1 plus 1, there's 6 of these. So since it's a constant here, it's going to be this many times So 6 times 1, so this is going to be plus 6. If that confuses you, please stop, work it out, make sure you understand that. This is not something that you can just gloss over, because you're going to have to know this. Anyway, now what I can do is I can choose to, I'm going to change colors here. I can choose to evaluate this using the fact. So this is 1/6. Make sure you keep these parentheses right. I've got 2. Now I'm going to have n, which is 6, times n plus 1, which is 7, times 2 times 6 plus 1. 2n plus 1 over 6, and then this is plus 6. So this is 1/6, and this is 2, and I'm not going to cancel this and this yet. I'm going to leave the denominators the same. In fact, I'm going to take the 2 up to the top here, and well, no, I guess it doesn't matter. I am going to cancel this 6 and this 6. Now I have numbers, so I've got 2 times 7 times 2 times 6 is 12, plus 1 is 13, plus 6, okay, all over 6. So this is going to be 14 times 13. And 14 times, let's see, so I'm going to get 182 plus 6, which is going to give me 188 over 6, which is 94 over 3. So that is the expected value of that. All right. Now, please remember, scan in your lecture notes for this video before midnight of the due date that's listed on the course calendar. Again, make them neat for you. You don't start a formula sheet. Update your formula sheet. Update your formula sheet with what you need from this. So update. I need to change that. And again, make that list of definitions, theorems, corollaries, and remarks. You'll also want to add your facts that I gave you to your formula sheet. And if you have questions, come to the virtual office hours. If those really don't work for you, by all means, email me, and we will see you